Okay, so this review is going to be as quick as possible because it is kind of a long packet. This is for the multiple choice and free response part of the final exam. So for Mrs. Abruzzo's pre-calc classes, that's going to happen Wednesday, December 19th, I believe. And then you got to follow your final exam schedules. So first couple of questions here. You do have to know your formulas for both distance and midpoint, so keep that in mind. As far as studying goes, you do need to memorize this one. So the official formula for distance is, whoops, that's ugly, x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and then taking the square root of that. So Pythagorean theorem at its essence, and I kind of take a shortcut when I do distance formula because I'm lazy. So when we look at the x's, I think about, okay, negative 11 to 3 is 14 units. So I just write down it's a distance of 14 units squared, plus 2 to 5 would be 3 units squared. And then the way the question works out on the final, I believe it's either a radical that doesn't reduce, or it's like you round to the nearest tenth. So this comes out to square root of 205, I believe, which is approximately 14.3. So not sure how it looks on the final. Forgot. So midpoint is an ordered pair. And it's the average x and the average y. So x1 plus x2 divided by 2. It's been a long time since we tested this, and some of you did not have your formulas memorized. I mean, I like to say no judgment, but pre-calc, a lot of judgment. You got to get those formulas memorized, all right? So midpoint for these two ordered pairs. Again, I kind of cheat, and I do a lot of this in my head, which is a little dangerous on a final exam, but you might want to think about where you're going to save time in case you're worried about time. I wouldn't be worried about time. It's a pretty short test. Let's see. Negative 11 plus 3 is negative 8 divided by 2, so negative 4. And then, excuse me, 2 plus 5 is 7 divided by 2, which you can write as 3.5 or 7 halves. Knowing us, it's probably written as a fraction if that was on the final. Right here, you're going to subtract f minus g. Just make sure that when you subtract function g, that you are subtracting all of it. So you need to make sure that you not only subtract the 4x, but you're also subtracting the negative 1, which makes that a positive 1. So when you simplify all your like terms, I believe you end up with x squared, let's see, x squared minus 6x plus 5. So make sure you're able to get that answer. This next question is an evaluation question for a quadratic function where they want you to plug in, instead of x, they want you to substitute in a plus 5. So parentheses are key, and knowing how to use those parentheses properly is also key. So substituting in an a plus 5, and you all know which part I'm worried about. It's that first binomial that's being squared. You have to remember that a plus 5 quantity squared is a quadratic of a squared plus 10a plus 25. If you have to write that out the long way, you go right ahead. And then continue distributing this time the 4, so plus 4a plus 20, and then plus 8. And when you simplify and collect all your like terms, looks like we get a squared plus 14a plus 53, I think. Yeah, I don't know. Sometimes I can't add. Apologies if I do things wrong. This will be a multiple choice question. So I know that makes some of you think it's going to be easy, but sometimes multiple choice questions are more difficult because the common mistakes, we are very aware of your common mistakes, unfortunately, so we make sure that one of those common mistake questions gets put on one of the choices. So the next question asks about the concept of a function that also has an inverse that's a function. In other words, I'm looking for a function that is 1-to-1. So the idea is this thing that you're about to graph has to pass the vertical and the horizontal line test. So it'll be multiple choice, so you choose the one that passes both vertical and horizontal line test, and when I have to freehand one, I usually graph something that looks like that. All right, here you're solving a logarithmic equation. However, you do need to condense these logarithms together first. So log minus log turns into a division problem, where 2x over 7 is inside that logarithm now. And then technically what you're doing is you're exponentiating both sides with a 4, but because of the 1-to-1 property, you're probably not going to have a lot of difficulty understanding that you are setting up a 2x over 7 equals 40. You cross multiply and divide, and then it looks like we end up with x equals 140 as the final solution. All right, number 6 asks about domain and range of an exponential and logarithmic function. So remember, exponential functions, this is a growth function, so it's going to look like this. The domain is that easy negative infinity to infinity. The one that is the logarithm, however, I'm a little concerned about because you guys sometimes forget that there's a vertical asymptote. So the domain goes from 0 to infinity. Make sure there's a parenthesis on 0 and not a bracket. I do want to caution you with it being multiple choice. Any common mistake that happens on this question, trust me when I tell you, it will be a choice. Alright, this next question, these two questions are about operations with complex numbers, and you're going to multiply these complex numbers together first. So what is that, a negative 72 minus 30i, and then plus 12i, and then plus 5i squared. And your choices, you're going to want to look for, first of all, a question that's in a plus bi form, which means you're going to combine these together and get negative 18i. And the other thing that you're going to have to remember to simplify is I squared is negative 1. So this term right here is really a negative 5. So when you combine the negative 72 minus 5, you get negative 77. That's your a plus bi form that we are looking for. Then, when I look at the next question with division, remember that you can't divide by a complex number because it's the same thing as a radical. So in order to rationalize, you're going to use what's called the conjugate, the complex conjugate. So instead of 1 minus 4i, you're going to use 1 plus 4i. So distributing out the numerator here, ooh, that's ugly. You get 2, let's see, plus 8i plus 5i, and then plus 20i squared over, I gotta distribute the denominator. Conjugates work out really nicely, and if you know the shortcut, you can take it. But 1, and then you have a plus 4i and a minus 4i. That's the cancellation that should happen. And then a minus 16i squared. So again, simplifying, collecting like terms, and remembering that I squared is really a negative 1. Makes this term a minus 20, and it makes this term really a plus 16. These cancel. These add together to give you a 13i. So my numerator simplifies to, let's see, a 2 minus 20 is negative 18 plus 13i. And then 1 plus 17 in the denominator becomes, plus 16 becomes a 17. But the answer you're going to be looking for, because it'll be in a plus bi form, is this. So usually my students' next question is, oh, but what if I use my calculator a little more than you did, Mrs. Abruzzo? And I said, well, I guess I'll never know. All right, moving on. Number 8. Slope-intercept form of the equation goes through that line and is perpendicular to this line. So perpendicular, remember, means that your slope is the opposite reciprocal. So you're going to have a slope of positive 5 over 1, or positive 5, and then going through the ordered pair 5, 3. So for most of us, we learned that point-slope form, again, a formula you're going to have to memorize, or have memorized. It's really nice and easy to use here. So y minus the y coordinate would be 3. And then our new slope that we just found, 5. And then x minus the x coordinate, which is 5. And the answer choices will only be in slope-intercept form, so you're going to need to distribute the 5. And then add the 3 over, of course. So 5x minus 22 would be your slope-intercept form of that equation. There's other ways to get to that point, and since it's multiple choice, you can kind of deduce your way to the right answer. All right, number 9, you need to fully factor this, knowing that x plus 2 is a factor. So what I would set up synthetic division with the known factors solution. So negative 2, and then set up your coefficients from your dividend here. But looks like there's no missing term. Sometimes we sneak in a missing term. You got to be careful. So 1, negative 5, negative 8, and 12. So since this is a factor, you better get 0 for a remainder. Let's see what happens. So we multiply 1 times negative 2, and then we add up. Negative 5 plus negative 2 is negative 7. Multiply again, that's a 14. That's a 6, and then, yep, we did a good job because you do get a remainder of 0. So now this leftover quotient here, these are the coefficients to what's left over. So this is x squared minus 7x plus 6, which then you guys got to go ahead and take further factoring. So x minus 6 times x minus 1, but that is not your final answer, because remember, You had that original given factor, which was x plus 2. So that's going to be your final answer, and be careful on that question. Again, it's multiple choice, so it's designed to be tricky and try to distract you from the right answer. Okay, domain of anything with a square root symbol means that whatever's underneath the square root symbol has to be positive. So you could set up, and you could also graph this, that would work, but 2x plus 5 has to be greater than or could be equal to 0. So when you solve that, subtracting 5 and dividing by 2, you get x has to be greater than or equal to negative 5 halves, and then they want interval notation. So that means everything greater than or equal to 5 halves. Looks like so. Again, graphing works great on that question if you're ever stuck. Okay, this is a recent question. We give you a feasible region with all the different vertices, and you're supposed to plug them into the profit function. And I think I kind of cheated because I think we figured out that the max profit usually occurs at one of these. So I'm pretty sure I found the right one. I got a max profit of 410 at the ordered pair 811. Now, again, apologies if I wasn't thorough enough. I'm pretty sure that's the maximum, though. However, to be safe on your test, I would suggest you plug in every single vertex, just in case the profit function's a little weird. But I think I did that one okay. I'm not sure. Pretty sure. Alright, here we are graphing, oh boy, piecewise. So I would suggest you start by placing boundary lines in your graph. Again, this is on your final exam day. This is actually like a do-it-by-hand question. This is not a multiple choice question, so keep that in mind. So boundary line at -3 and at 2. And this part right here, this is a quadratic function that's been shifted down 5. So what I always like you guys to do is find the ordered pairs that are on the boundary lines. So like for instance at -3, if you plug it into that function, you get 9 minus 5, so 4. And I notice it's got an equal to symbol, so it's going to be a filled in circle at -3, 4. And then the other side of the boundary lines for that function would be 2, but this time it's going to be an open circle because it doesn't have an equal to bar on the 2. So when you plug in a 2, you get 4 minus 5, so -1. So at 2, -1, give me an open circle, but this is not a straight connection. This is a quadratic function, so you either would have to get points off your table, or you'd have to use your imagination and realize it's a quadratic that was at the origin, but was shifted down 5. And then from here, you can kind of fudge it in. Unless you're me and you can't draw, and then you can't do anything. Okay, that was supposed to be a quadratic. And then this is a line, which only has one side of the boundary line that we have to worry about. That was at x equals 2 with a filled-in circle this time. And something a little unusual happens on this question. When you plug in a 2, you get -1. So where we used to have an open circle on the green function, it's going to fill in with this red function, and then it's a line, so a slope of up 1 over 1. You could graph that one various ways, but again, guys, use your graphing calculator if you're ever in a jam. That's why it's there. Alright, so picking up at... Sorry, I kind of left my video, came back. Hopefully this edits properly. We are graphing another piecewise function. We have two boundary lines this time at -3 and at 0. There's our -3. Yeah, it's straight. Here's 0. And then for our first function, we have a quadratic function. So I'm going to do the same thing I did last time with getting the boundary line points, and then we'll kind of fudge in a quadratic in between there. So at -3, you're going to have a filled-in circle because it does equal to. And then if you go ahead and evaluate this function at -3, you get 2 times 1, -2. So at -3, -2, we have a closed circle like so. And then at 0, you're going to have an open circle because it doesn't say equal to on that one. So let's see, that's 2, 4. 2 times 4 is 8. 8 minus 4 is 4. So open circle at 0, 4. Woo, what happened there? So open circle at 0, 4. Come on, pen. Oh my goodness. Don't fail me now. Here we go. It's the end of the year. You can't stop working now. Okay, that's like a motto for this week, huh? Oh my gosh, guys, this is really rough shape here. Let me just try something. Alright, I think I have it working now. So at 0, 4, we have an open circle. That doesn't make sense, though. Something's weird. Oh, well, we'll figure it out. Alright, so we have this quadratic. Oh, I guess that makes a little sense. So we have a quadratic that you can use points off your table if you're not sure exactly what it looks like, but oh my goodness, what is this thing doing? It's got a vertex at -2, -4, which I'm going to try really hard to graph if my pen will cooperate. So -2, -4 is the vertex, and then I'm just going to fudge in an awful graph since my pen's not working either. And then your secondary function is a horizontal line at -3. So if my pen will decide to work right here. So at -3 with a filled in circle at 0, and then for the remainder of its domain is a little horizontal line. Alright, I really hope my pen starts working. Let's try the next one. We're factoring. So factoring 8x squared minus 3, that is the difference of two cubes pattern, which you must have memorized. It factors into a minus b times a squared plus ab plus b squared. So a is the cube root of this number, so that would be a 2x. And then b is the cube root of that number, it would be a 1, so 2x minus 1. And then watch this first term. You got to make sure you square both the 2 and the x, so that's a 4x squared. So thinking about how evil a math teacher could be, and the answer is pretty stinking evil, make sure that when you are looking for your correct multiple choice answer that you pick the one that says 4x squared, or the obvious right answer here, because a very common mistake is a child who just says 2x squared and forgets to square the coefficient. But we know that would be weird. Alright, so this pattern is the sum of two cubes, so it's a plus b times a squared minus ab plus b squared. So using that pattern, cube root these terms, cube root this term, again you have to memorize it. So it's 5x plus 3, and then same issue, I want you to be worried about a squared would be a 25x squared. And then minus a times b plus b squared. So that, again, multiple choice questions, so watch out. Here we're solving. I think solving by square rooting would be beautiful. Definitely don't distribute that 2. You want to divide by that 2. So x plus 1 squared equals 25. And then here, when you square root both sides, this is where the positive and negative solutions show up. So you have x plus 1 equals both positive and negative 5. And then I'm not going to be real happy if you think your answer is -1 plus and minus 5, and that's how you would indicate your answer. Because, again, multiple choice question, I would take this all the way down to the 2 solutions. So -1 plus 5 is a 4, and then -1 minus 5 is -6. So there we go for that question. Let's box that in so my slide viewers can actually see what I did. Oh, this. So transformations, you're going to be matching and finding a. For the absolute value questions, those are actually pretty easy because you can just count the slope of the branch to find a. The formula is x minus h, absolute value of x minus h plus k with the a in front. So here, your vertex is at positive 1, -3. So there's your h and k. And then your a value would be, if you could count, so like up 1 over, it looks like it's up 1 over 2. So for the sake of how you're going to be tested, you're going to be able to deduce the proper answer, I guess is a good way of saying it. So clearly a positive a value. It has some sort of a fraction slope that's smaller than 1 because it is wider. So x minus h, absolute value of that, and then plus k would be a minus 3. Similarly here, your vertex looks to be at -1, 4. And then if you count for your slope, this one might be a little tricky. 1, 2, 3. It looks like the branch is going down 3 over 1. I'm kind of guessing on that one, so hopefully that's right. So -3 times the absolute value of, instead of x minus -1, y'all would write x plus 1 and then plus 4. So for this quadratic, we learned our lesson the hard way on some of our tests. Sometimes the a value is not obvious. This one you guys might be able to guess that it's a little wider than normal and it's upside down, so that means the a value definitely has to be negative. And we're probably looking at a fraction for a. But what we would expect you to do normally is to use another ordered pair. So like if I'm going to claim that this goes through the ordered pair 3, 1, I would go find a that way. So this is the ordered pair 1, 3. That's a little confusing. So if I go to write my function with x and y and h and k plugged in, I would set up y equals, I don't know, a, and then x value of the point, 3, minus h, don't forget the squared, plus k, which is 3. So since everything was a 3 and 1, that was uber confusing. So this is the red 1, this is the red 3. If that helps you any. Either way, you need to simplify this. So you'd first subtract 3 to the other side. So you'd get, right up here, so you'd get, let's see, negative 2 equals a times 2 squared, which is 4. And then divide both sides by 4, and looks like our guess of negative 1/2, which is probably what you guys were going to guess, was actually very correct. So negative 1/2 is the a value, and then in the x minus h quantity squared part of the formula, it looks like that now, and then plus k. So again, if this is a matching question or a multiple choice question, you should be able to deduce your way to the right answer pretty quickly. Is it even? Is it odd? Is it neither? So one way to figure this out is you could graph them. Even functions have symmetry of the y-axis. Odd functions have symmetry of the origin. And then neither would be neither of those, of course. So the other way to test whether they're even, odd, or neither is to kind of make a guess at first, and then plug in a negative x into the function. And the idea is if it gives you back, if it equals the original function, that means you have an even function. But if you plug in, I should write s of, if you plug in a negative x into your function and it gives you the opposite function, so like everything changed signs, that means you have an odd function. So that's the algebraic test, but a lot of you really enjoyed looking at the graph, so it's up to you. I, of course, can't graph, so I like to test the algebra. So like right here, if you plug in a negative x for all of your x's, so you have negative x to the third power, and then plus 4 times negative x. What that would simplify to, I'm going to work down here, would be negative x to the third power minus 4x. And if I look at my original versus my new one, I notice everybody has the opposite signs, so that's why I can claim that this is an odd function. This one's not too bad to plug in a negative x right here. It would end up being this, which of course would reduce to a positive 2 over x, which is the opposite function again. So you have another odd function, which you can see the symmetry if you graph it, by the way. This one is pretty clearly a neither. You can try graphing it. I mean, it's square root graph who kind of looks like this, which doesn't really have any symmetry. And then here, if you graphed it, you would see like a W looking thing. But if you do the algebraic test, which means you plug in a negative x for all the x's, notice the even exponents that has, I mean, it's not exact science when people say, oh, there's even exponents, it must be an even function. It does have something to do with the math, though, because look at this. Negative x to the fourth power, that's going to reduce to positive x to the fourth power back again, and then negative x squared will also come back to positive 5x squared. So since this is the same function that you started with, that's how we can claim that we have an even function. And of course, you know, looking at the powers does help. It helps you kind of guide your decision. Sometimes the function is weird, though. All right, so on your review, you're going to see what's called a gridded response question, and this is the way it's going to be asked of you on the test as well. So get familiar with how to bubble these in. This is also kind of getting us ready for the SAT test. I'm going to use my finance app on my calculator and a house loan for $106,000. So this is what you're going to put in for the present value. And for the sake of time, I'm not actually going to go through these steps, but I want you guys to try. Exactly right, 8 for interest. This is time, of course. So when you go to fill in N, you're going to do 20 years times monthly payments, so times 12. You don't even have to simplify it. Remember, the calculator will do it all for you. Let's see, we got present value, we have interest. The monthly payment, I don't remember what they call it all of a sudden. Payment. I think it's called this, PMT. That's what you're trying to solve for, right? So this is what you're going to do, alpha, enter. And that's how you solve. Compoundings per year, all that is 12 because it's monthly. So after you, I'm just going to steal my answer. I want you trying to type that in your finance app. You guys actually did a beautiful job on that last time we tested this. And this is money, of course, so you want to round to an appropriate amount. I got $886.63 for a mortgage payment every month, which makes sense. I mean, you guys don't pay mortgages, but that's pretty standard. So $886.63, you pay that every single month over the course of 20 years. So the question is, how much did you actually end up paying for this $106,000 house? And the answer is you paid more than double that, $212,791.20. Don't you dare forget that 20 cents. All right. So using your finance app, that's great, but now you got to bubble it in. So it seems, oh, okay. So the monthly payment is the one that I'm going to ask you to fill in here, right? So you do, actually, you know what? I lied. This is not on your graded response part of your test. Scrap that. All right, moving on. Well, we could have. All right, so this one, an oldie but a goodie, right? We're trying to solve equations with fractions, but no one likes fractions, so we multiply by an LCM. I would use a 30 on this one, and I would distribute the 30 to everybody, which gives you, let's see, 5x plus, let's see, it's a 12. Don't forget that 2x is also being multiplied by 30. And then 11 halves times 30 is, yeah, I should be able to do that, but I can't, 165. And after you move some terms around, let's see, you get 177 equals 55x. And this comes out to a gross fraction, but that's okay. 177 over 55, which does not reduce, I don't believe. All right, this question, no decimals, so graphing's not going to work, and you can't like simplify it weird. You can solve it however you want. You can do quadratic formula. You can do completing the square. This one does not factor, however. So I like completing the square. I just like it, so I'm going to use it. X squared plus 4x plus blank. I'm going to add the 11 over, and then I'm going to balance out my completing the square. So remember, completing the square, you take half of this number. So you take your middle number divided by 2, and then you square it. So that would be 4. And the reason you did that is because this trinomial is going to factor really beautifully into a squared binomial. Now, if you hate this method, that's fine. Choose another method. I get x plus 2 equals, this is where the positive and negative shows up, and then 15, square root of 15 will not reduce. So your exact answers are negative 2, both plus and minus the square root of 15. You don't have to separate them, but don't be alarmed if they are separated on the multiple choice. Like they might say negative 2 plus square root of 15 and negative 2 minus square root of 15. Alright, so quadratic formula is an okay option for solving that, but that means you have to know quadratic formula. Alright, this one, we're going to square both sides. Whoops. On the left side, the square root and square functions will cancel each other out, and you get x plus 5. But on the right side here, remember you're foiling that out. So it's x squared minus 30x's plus 225. And of course, they give us a quadratic. So typically these come out to factoring questions. If I it's a negative 31x, subtract the x, subtract the 5. And for the life of me, I don't know why this one took me forever to factor, but it did. I think I settled on, what did I settle on? Negative 11 and negative 20, because that adds up to 31. So you get x equals 11 and x equals 20, but we're remembering now that these are tricky because sometimes when you plug them back into the original, they don't work. Like for instance, if you plug in an 11 right here, you get 11 minus 15, which is negative 4. Well, a square root can't equal a negative 4, so that one's extraneous. And then just trust me when I tell you 20 totally works. Alright, moving along. Everyone's favorite, a rational equation. This quadratic, you need to write in its factored form, so that way you can use your LCM and knock out all the denominators. So common multiple for this question would be you need to knock out an x and an x plus 3. And when you distribute that to each fraction, you can write this out the long way if you want. I'm just going to write down what doesn't cancel, basically. So in this first fraction, the x plus 3's will cancel, which means you still have an x times a 2x. Minus, now this next fraction, the x plus 3's will cancel. I'm sorry, the x's will cancel. So you still have a minus 3, and then you're multiplying it by an x plus 3. And then on our last fraction, the x and x plus 3's cancel, so you have just the 5 left over. So now, of course, we end up with a quadratic. So this will be fun. We get to solve 2x squared minus 3x minus 9 equals 5. And then subtracting 5 from both sides. There's your quadratic in standard form. And of course we got a factor, because why not? We're pre-calc. Again, you need to worry about extraneous solutions here, so just be careful. I'm going to go with 2 minus 7. Okay, so if I make this a minus 7 and a plus 2, that'll be a positive 4 and a negative 7, which adds up to negative 3. So we have a solution at 7 halves, and we have a solution at negative 2, and I was silly. I should have started the question with like answers that were restricted. I couldn't have negative 3, and I couldn't have 0, which I didn't get either one of them. So we're going to count both as good solutions. Alright, here, you do have a formula for this. I think it's like a sub naught, I don't remember if it says 1 plus r maybe to the t power. That's the formula you're supposed to use. I forget what variables they use, but it's all kind of the same thing. So your initial population goes first. And then in the parentheses, it's either 1 plus or 1 minus the rate, depending on whether it's increasing or decreasing. Now, because it's decreasing, you have to subtract the rate, right? 1 minus 0.02. And then to the x power, to the t power, whatever you want to count it as. This is kind of a boring question. Oh, my answer key's wrong. Darn it. Because this is weird. Alright. 2000, the census was this. So in 2020, that means that's 20 years later. I don't know what happened there. I don't know what's going on. Alright, so the population 20 years later, I don't know what it is. You'd have to plug it in, because apparently I didn't do it. So I'm going to need to fix that. Darn it. Abruzzo, you need to learn to read, girl. Alright. You know what? While we're here, let me just go ahead and fix that. Whoopsies. Alright, 148,522 times, I'm just going to write that as 0.98. But you do whatever you need to do. Now these are people, right? So we should be appropriately rounding. So I'm going to write down 99,154. My bad. Alright. Here is the gridded response section. So you're going to be solving and you're going to be bubbling in your answer appropriately. So common base would be a 2. So leave this one as it is. But rewrite 8 as 2 to the 3rd power, but then realizing that there's already a power on top of that. So you're going to need to multiply these together, but be careful, the 2x minus 5, everything has to be multiplied by a 3. So you have 2 to the 3x is supposed to equal 2 to the 6x minus 15 power. And the only way for this to happen would be if your powers match. So now this is called the common base or the baby base method. 3x has to be the same thing as 6x minus 15. Subtracting something over, I don't know, I'm probably going to just subtract the 6x over. So negative 3x equals negative 15, which means x equals 5. So you're going to be bubbling in. Notice there's no negative option for bubbling in. I would just put 5 in the first box and then bubble in the first 5 to go with it. And that's how the machine is going to read it. So you might be asking, well, what if I put 5 somewhere else in the box? That's fine. Just don't put anything weird like 005. I don't think it's going to count that right. I don't know. I'm not sure. So don't get weird. Alright, you're going to be using properties of logs to condense. So anything with a negative log means that that's going to end up in our denominator. So we have a natural log of, these are positive logs, right, here and here. So numerator, numerator, so that would be 5 times a plus 4. You don't even have to make that pretty. I don't care. And then in the denominator, you're going to have a y. If it is a multiple choice question, you might see 5a plus 20. I'm not sure what section this one shows up on. It might be on the free response. It might be multiple choice. I don't know. Alright, so same idea here. We have a negative logarithm, so that's going to be in the denominator. These guys are positives, so they're in the numerator. You have a log base 5 this time. And then, up in your numerator, you got to also be careful. Some things have powers that need to come back up. So in your numerator, you have 6 times b to the 1/2 power, which I always write as the square root of b. And then down in the denominator, you're going to have c to the 2nd power. That's probably the answer you would see on a multiple choice question, so make sure you know how to find equivalent answers, even if yours doesn't quite look like that. So here you have a logarithm base 7, and you got 3 things going on here, and they're all being multiplied together. So when you expand that out, it's log base 7 of 9 plus log base 7 of b plus, and then it's log base 7 of t, but it's to the 1/3 power. That's the same thing as cube root, so we know we're going to have to bring that 1/3 power down in front. Again, full expansion, you got to make sure you choose the correct answer if it's multiple choice. Now, be careful here. You have 2 things in the numerator and 2 things in the denominator. So that tells me that you're going to have log plus log for the numerator stuff. Let's talk about that first. Come on, Abruzzo. Oh, that blue pen is really messing with me today. Okay, so natural log of 6 plus natural log of, whoopsies, I should have given myself more space. Instead of x to the 3rd power, I'm just going to sneak the 3rd power in front of that logarithm. And then in your denominator, you have 2 things. So you're going to be subtracting the natural log of 3, and you're also subtracting the natural log of a minus 2. Now, we haven't talked much about parentheses in these questions. I always like parentheses around things in my logarithms. They're always a good idea. And in one case here, they're mandatory. You must have these parentheses right here where it says a minus 2. Otherwise, we can't tell what's in the logarithm. Alrighty. I feel like we just did that question. Yep, sure did. Okay. Here's another gridded response question. So I want to know how much money is in your bank account after 4 years. Notice how you round to near cent, of course. So the compounding formula states that you start with the principal, and then 1 plus your interest rate over a number of collections per year, and then to the n times t power. So we're going to be in our home screen of our calculator. You could use the finance app if you'd like, but it's kind of cumbersome for this. 1 plus 0.043 compounded monthly, so over 12. And then up here, if your old calculator needs parentheses, make sure you use it. Otherwise, it's 12 times 4 up in the exponent. So after typing that in my home screen, I get, what do I get? So I'm going to write this number down, 2968.28, and then I'm going to also do the gridded response properly. So 2968.28. And then you bubble, of course, which is, yes, I know it's annoying, but we got to get used to doing this so that the way the machine gives us credit when we deserve credit. Decimal point's already included in this one. On the SAT, I think you have to physically bubble the decimal point. I won't swear to that, but I'm pretty sure. Now, if you get an answer that doesn't fit in the allotted boxes, that means you've probably done something wrong, or possibly your teacher did something wrong, which that might be likely. Okay, but I'm pretty sure we checked the final over a few times, so we don't have any mistakes on it. All right, here we have one of those logarithmic growth questions. So what you're going to want to do probably is type this into y1. Just make sure that you have this denominator all in parentheses. And then you're going to figure out at 2 months, and this is measuring in months, so you don't have to do anything weird with that. But basically, x or t, or whatever you want to call it, you need to plug in a 2. And then round to the nearest whole fish. Notice the directions. So the answer comes out to 148 when you round. It's like 147.7. So that's what it'll be bubbling in. Of course. I know you guys are like, really? You're going to teach me how to bubble? Well, yeah, because I don't want you to freak out in the middle of your SAT test, or your final for that matter. Same function. I want to know when you hit 3,400 fish. So you're going to have to put y2 as 3,400, and then on your calculator, once you get a good window, you're going to see, a logistic growth, and then you're going to see a line at 3,400, and you got to figure out when they intersect each other. And then, of course, it'll be the x value rounded to the nearest tenth, as it describes in the problem. I got 23.2. So I would go 2, 3, the decimal point's already there, 2, and then I'd bubble. Easy enough, right? So these are ways for your teachers to ask you, and the SAT, multiple choice questions without actually giving you the choices, because let's be honest, I think we've all been in a situation where we kind of lucked out on a multiple choice test and got it right, even though maybe we didn't really know what we were doing. All right, be careful on this question. Vocab, very important here. I want the extreme value for the function. When it says the value of the function, they're looking for a y value. So when you graph this quadratic, it's an upside down parabola with a vertex at 311, right? So, it's going to look like this. So the vertex is the maximum in this case, and the maximum value would be the 11. If you weren't sure, then go graph it and just go look. But be careful, if this is a multiple choice question, you better bet that I put x, like 3 as an answer choice, even though 3 is not the value for the function because it's an x value. All right, now this next question does say specifically I want an x coordinate for the vertex. So you can either find it through graphing, or you can use the symmetry formula for a standard form of a parabola, which is negative b over 2a. You could do all sorts of things to that question. If I know you guys pretty well, you're probably just going to graph it, and I think there's no shame in that. So opposite of b is positive 12 over 2 times a, which would be 2 times 3, so 12 over 6, better known as 2. Remember, they just want the x value in that second question. All right, locate the whole. Sure thing. Got a factor, huh? Lots of factoring in this question. So it factors into 2x plus 3 times 2x minus 3 in your numerator. And then your denominator factors into, let's see here. Let's do a minus 5 and a plus 3. So these are the factors that cancel, which means your whole has an x value at the solution to that factor. So if you were to set that factor equal to 0, you'd get negative 3/2. However, multiple choice question, I can guarantee you there's more than one choice where x equals negative 3/2 or whatever the answer is. So now to find the y value, you got to go plug in negative 3/2, which is the same thing as negative 1.5, by the way, into the remaining parts of your function. So 2 times negative 1.5 minus 3 over negative 1.5 minus 5. If you are a happy calculator typer, make sure you either hit enter or use parentheses when you're dividing this part right here. And I think when you hit math enter, it comes out to a 12 over 13. So that would be the location of the whole. That is the messiest question I've ever done. I apologize. My work is everywhere. All right, we are solving this one. I'm going to be applying a logarithm, but I wasn't quite ready yet. So 6 to the x power equals 34. And then you know Abruzzo's going to apply her favorite logarithm, the natural logarithm. Nothing cancels. However, what does happen is your x gets brought down, and now it's being multiplied by the natural log of 6. And it equals the natural log of 34. So final step here, you just divide both sides by natural log of 6. The question could be written in exact form on the multiple choice test, or it could be decimal form. So natural log of 34 over natural log of 6 is an okay answer, but if it wants you to approximate, then you'll say it's about 1.9. Good times, good times. All right, almost there. Oh, blast the matching. All right, here's the ones I want you to really focus on. This versus this. Super important, right? So when there's a negative out in front, it reflects vertically, so over the x-axis. And as I'm looking at my answer key, I matched that one up with E. So let's take a look at E. Do you see it? So here's the original one. And down here is E. So it reflected over the x-axis, a vertical reflection. That's what happens when you throw a negative in front. However, when you throw a negative inside your function, that reflects, can't write, reflects over the y-axis. That is a horizontal reflection. So it's going to be reflecting this way. So when I look at my answer key, I match that up with C. Let's check it out. Yep, and I was kind of eyeballing this weird little curvy part because it was over here and now it's over here, I think. Did I do that right? Oh man, wrong way. I mean, I'm feeling good about that. If I'm wrong on the answer key, I apologize. Okay? And then we kind of tried to group them together. So like, what's the difference between these two? Well, when there's a 2 in front, it's a vertical stretch, which I can't spell. And if there's a 2 on the inside, that is a horizontal shrink. So you're going to be, according to my answer key, again, I might be wrong, I think this one matches up with I, and this one matches up with F. Hopefully I'm not wrong. I did this really fast. Now these two kind of go together. And a divide by 2 is the same thing as multiplying a 1/2 in front of your function. So this one here is a vertical shrink. But a 1/2 inside the function is actually going to be a horizontal stretch. Remember, horizontal things are opposite when they're inside the function. So according to my answer key, this matches up with A and this matches up with B. The absolute value one's kind of weird. All it does is when it's around the function like this, it takes all the negative parts and flips them. So the stuff underneath the x-axis, the negative parts, reflect up. For this one. So according to my answer key, I matched that up with K. And then this function's really hard to tell when it's been shifted right or left because it's a bad copy, frankly, guys. So the function notation, I know this means left 6 and this means right 6, but actually matching it to the graph was kind of challenging for me. I don't know if it's because I'm old or what, but I said this was H and this was G. And then here, this one has a lot going on. Alright, so this in order, it's reflected first and then shifted right 3 and then up 5. So you have to be careful because this one has a reflection, then left 3, then down 5. So the reflection has to happen first. And those are really hard for even me to match up, guys. Those are challenging. The good news is on your test, you're only matching like 3 graphs. So it's not like you have to match all of these graphs. That was uber challenging, wasn't it? All right, I think that was the end. So good luck, everybody, on your final. This is the last piece of the final. It's another third of your score. And I hope you all have a good, winter break, and we'll see y'all in January.